Hey guys, what's up? Welcome to Code and today we are going to discuss a interesting problem called minimize deviation in array. It's very interesting. It's an hard level question, but I feel it ranges from medium to hard. It's not that hard. It's a really very interesting problem, and yeah, before we discuss the problem, there are a lot of videos which we have already covered on DSA. Do check those videos out, and there are a lot videos more to come, so stay tuned. So yeah, let's come back to our problem. So what is the problem? So we are given a array num of n positive integer. Okay, so what we have to do is if you're finding element which is even, divide it by 2. Okay, you can divide any number. If you are finding an odd element, multiply by with 2. You can do to any number, but the main thing is you have to return the minimum deviation. What is minimum deviation? Minimum deviation is a minimum difference between the max and the minimum value. For example, let's take this value, this one. In this we have 1 2 3 4, right? 1 2 3 4. So what they did is you can transfer the array to 1 2 3 2 by 2. We can divide 4 2 by 2, so because it's even, so it becomes 2. Then we are multiplying 1 into 2, because it's odd, we can multiply, so it becomes 2 2 3 2. So now in this the max value is 3, the minimum value is 2, so the minimum deviation will be 1, right? Cool. So in this problem we have 4 1 5 23, right? So what they did is they took the max value and just divided into by 2 twice, because the 20 by 2 is 10, 10 by 2 is 5. So they decomposed 20 into 5, and they multiplied 1 by 2. So now the max value is 5, the minimum value is 2, right? So what will be the minimum deviation? It is 5 minus 2, max minus minimum, to equal to 3. Cool. This is the problem. So if you have not understood, also I'll just explain you briefly, but try to understand it as much as you can, because it might be confusing as well. So let me just start with the presentation. uh, if you didn't get it, just rewind the video and just uh, repeat the video once again, so that you will understand it. Cool. So let's start our implementation part. So basically what is our approach is, what we just observe here. The thing to observe here is, in this, when you observe the odd values, just observe the odd values. If you see the odd values, if you're multiplying the odd values, it becomes even, right? Obviously, if you're multiplying any odd value, it becomes even value. So what can we observe? We can observe that we can only apply one operation at once on odd operation, because after one operation it becomes even. One operation at once, that is the key thing to observe here. So what we are doing is, see, there are two operations, that is, we also have to concentrate on odd. That is, if it is odd, we have to multiply it by 2, right? And there is also even. If we see even, we have to divide it by 2, right? We have to divide it by 2. So it's really disturbing. I mean, why it's disturbing? We have to track both odd and even, right? So what we'll do is, to simplify this, we will cancel out odd. How we are cancel out? How, like, you can ask, like, how is it possible? Like, how you can just directly cancel odd? So for that, what we are doing is, we wherever we find odd values, we multiply it so that it becomes even, right? Because we know that only one operation applies. If you're just applying one operation on odd, it becomes even, right? So wherever we are finding odd value, just multiply it by 2, So when you are multiplying it, all the if you are multiplying the into 2 to all the odd operation, all the values, can I say that all the values becomes even? Yes, you can say, right? Let me just show you. Let me just clear this out real quick. I hope you are getting to feel the question a bit. So so in this question, 4, 1, 5, 2, 20 and 3, in this we can observe there are three odd values. So we are converting all the odd values into even by multiplying it, right? Uh, so we know that for odd, if we have to, if you're finding an odd, you can multiply it. So what we are doing is wherever we find odd, we are multiplying. So let's do 4 into 2, that is 2, 5 into 2, that is 10, and 20, and this is 6. Let me just write this 10 properly so that you don't get confused. Right, these are the values. Cool. So now you can see that we have only even operation. So our one thing is fine. I mean, we have already dealt with the odd thing. We have deleted the odd thing. So now only thing to deal is with the even operation. How we can apply these even operation on these, so that this we can find the minimum deviation by separating the maximum and the minimum. So in this case, what we do is basically in our approach, in our code, we are taking a priority queue. You can also take a set. It doesn't make difference. But if you are taking a set, I mean, a little bit of the complexity reduces. That's it. So I mean, it's no, there is no much difference, but yeah, there is a bit difference, or if you are using set, it reduces a bit less complexity, right? Fine. So what we are doing is we are taking a priority queue, and after making this, after transferring all the odd to even, this set we had this uh, elements, right? So we push this into priority queue, that's max heap, into the max heap, right? Because we know that priority queue at default uses the max heap, right? So what we do is we just create a priority queue. Let's say we created a priority queue p. So we are pushing these elements into a priority queue. So how will the priority queue look? Now it will be like 20, because max will be in the front, then 10, then 6, then 4, then 2. This will be how the priority queue looks, right? I mean, after putting these elements into the priority queue. Cool. So now what we do is we just track the difference, that is the maximum minus the minimum, right? So what is the, let's take something like result. In this result, we just store the maximum minus the minimum. What is the current difference between the maximum and minimum? That is 20 minus 2, that is 18. Cool. So what we do is after getting the result, what we do is we just hop out the max element, the top element, and we divide it by 2. When you divide it by 2, it becomes 10, right? It becomes 10. So the uh, element will be again arranged in this way. So after this, we just update. I mean, now the max value is 10. 10 minus 2, now the new max is 10. 10 minus 2 is 8. So we again reduce this by 8. And one thing we have to note is we have to pop out, we have to do this operation until we find the top value to be an odd number, right? So unless the top value is odd, we do the same operation. So again, we find the top value, and we again pop this out, pop this out, and divide this divide this by 2 and insert this again. So this will be 5, right? We divide this by 2, again we insert this inside the uh, priority queue. So again, how will the priority queue look now? Again it will become like 10, 6, 5, 4 and 2. This is how now the priority queue looks. Again there is 10. 10 minus 2, again it's 8. So the result doesn't change. So again you are decreasing this by 2 and you are popping this out. But I mean you are reducing, you are dividing this by 2. This will become 5. Again you change uh, I mean you again insert it into a priority queue. So now how does it look? Let me just erase this. So it will be 65542, right? I hope you're getting it. If you're not getting it, please do rewind the video and check now, please. So it will be 65542 and 2, right? Now the top value is 6, right? So now the difference, now the difference is 6 minus 2, that is 4. Yeah, we are getting less value from this, it's better. So we just add this and we pop this and we divide this by 2, that is we get 3. Again the ordering, and again we'll push this into the priority queue. Again the ordering will change. That will be 5, 5, 4, 3, 2. So basically, as I said in the beginning, whenever you find the top value to be the odd number, just take the difference of this and just return the result, because there is no chance of getting less than this. I mean, getting less than this minimum. So just if you have a doubt like why can't, I mean, how can you be sure that why the other elements can't have the minimum? You can just go ahead and try, but you will get the same result itself. So when you find, as I said, when you find the odd element at the beginning, just return saying just taking the difference between the max and the minimum and returning the result. That's it. That's all we have to do in this. So I think explanation is pretty much clear. Let me go to the code. So this is a code. So what we are doing, as I said, first we are seeing the odd numbers and we are converting every odd numbers to even number, right? So this is where we are converting the odd number to even number. Now we are taking the max element and the minimum element and we are finding difference. This is the first iteration where we find the um, max minus min, and we are storing it in answer, and we are taking a typical priority queue. It's a max heap, and we are pushing the elements in the priority queue. So when you push it, it will be in the max heap, that is in the descending order. And Now as I said, we have to do the operation until we find the top equal to odd. When we find the top equal to odd, just come out of the loop, just find the new answer variable, that is the minimum deviation, that is top minus minimum value, and just return the answer. Okay, this is when it is odd. When it is even, just go inside, as I said, just pop the element and store it, and find the minimum deviation again, and divide the top by 2 and push it, and again find the minimum value, because it might change, right? The minimum value might change. So for emergency, write this to minimum equal to min, that is mn comma top. So this is basically how the code runs. If you're having any doubt, please do rewind the video and uh, uh, just understand until you get it. So yeah, let's run this. It has work. it it does work. So that is pretty much it from this video. If you understood something, do like the video, and there are a lot of videos, as I mentioned, do check these videos out too. There are a lot of good videos for practicing DSA, and there are more contents coming up, and we are also going with many development to like full stack development, and we are also doing some of the inspirational stories that will motivate you. So yeah, do check out the channel once. If you like the channel, do subscribe to the channel. Stay tuned. Till then, bye. Do coding. Keep coding. Thank you.